now I would like to welcome you to our talk today, our seminar on thermal adhesives. As we all know that sounds like a niche topic, thermal adhesives, but everybody in this room knows that whether it is semiconductor packaging or EV or any kind of electronics, it is absolutely mission critical. Without effective thermal management, even the most advanced chips can misbehave, and the most carefully engineered battery packs can end up running hotter than a firecracker on an oven. In short, thermal adhesives are not just glue. They are actually enablers of safety, reliability, and performance. We're also honored to have with us two distinguished speakers from China who bring with them decades of global expertise. And let me clarify, this is not just a learning experience. This is a knowledge sharing experience. This is about exchange between both India and China. We have scale, ambition, and a strong track record of innovation between both our countries. Today is about sharing insights so that we can leave this room better prepared for the future of mobility and electronics. Let me introduce our speakers. We have Dr. Eugene Zhu, Corporate Vice President of Darbond. He is a pioneer in semiconductor packaging materials. With nearly 30 years of experience, he has held leadership positions at Intel in US and now drives innovation at Darbond. His expertise spans R&D, process integration, and large-scale manufacturing. He has published 26 papers and holds 32 granted patents, including 5 in the US, and even 13 trade secrets. Don't worry, we won't ask him about those, maybe afterwards when we have drinks. We also have with us Dr. Chen, who is the CEO of Darbond Technologies. Dr. Chen is another internationally renowned expert in semiconductor materials. With over 20 years of R&D excellence, he has worked with Fortune 500 companies like Intel, Henkel, and Honeywell. His research covers everything from polymer materials to ultra-low dielectric materials for IC chips. He has published more than 50 papers and holds over 140 patents worldwide. To put it lightly, if knowledge were an adhesive, Dr. Chen would be classified as ultra-high bond strength. So together, Dr. Zhu and Dr. Chen will guide us through the cutting-edge developments in thermal adhesives, packaging technologies, and material science. Insights that directly impact industries like electric mobility, where efficient, safe, and long-lasting EV battery packs are a foundation of success. Before Dr. Chen and Dr. Zhu take the stage, I would also like to invite our very own Rohit Kumar, who is Head of Technology at Chembond, to give you a brief introduction about Chembond's products and the innovation that we are conducting at Chembond. Rohit.
Ladies and gentlemen, I just take you to the product. We introduced in last maybe around 2 years and some new technologies, which is really based on the latest challenges and opportunities with the automotive OEM. Our target adhesives and sealants, structural adhesives and NVH products. We are serving the entire value chain, starting from the body shop, paint shop, and assembly shop, entire value chain. We are also offering innovative solutions with respect to sustainability, lightweight, and efficiency improvement. We have a product range which is providing this. Our main focus is on these core topics like lightweight, sustainability, and efficiency improvement. And we are also willing to partner with the automotive OEMs is from the concept stage to provide a right solution at the right stage. Within Chembond, we have a complete design and development facility. We can concept from the concept stage to validation stage. We can definitely provide a customized solution based on individual requirement and individual shop requirement. Complete testing and evaluation, and as well as complete application process development for the product. If we talk about what are the main challenges and opportunities, if we look at the lightweight and energy saving, definitely it requires to achieve this lightweight and energy saving, we need a new material, which is plastics, composites, multi-metal, and to go with downsizing and e-vehicle. Next is like that we have to reduce the cost and manufacturing process, customization as I mentioned, customization of the product, low curing temperature, reduction in process steps, and complexity reduction. Nowadays, for performance, there is a high strength and durability is key requirement for all the vehicles. There are a lot of regulations and legislations are there to ensure the strength and durability of the product. The performance is definitely, expectation is very high. Nowadays, customer is aware about all these parameters. And apart from that, of course, the comfort level, like reduce noise, vibration, and harshness, as well as to improve vehicle interior air quality, reduce the smell or odor. So that is another important factor. And how to achieve all this? Like everyone to achieve more with less, and it is possible only with if once we have the right material at the right place. The mega trend, as I mentioned, fuel efficiency, sustainability, weight reduction, and new battery technologies. And if we look at it, still like roughly, this is the data we have taken from some source that still steel is contributing to around 57% of the body. The rest is like it is some alloys, some plastics and rubber and other components are also coming up to reduce the weight and improve the efficiency. Like when we have a multi-metal, multi-substrate kind of thing, then we definitely need a different kind of adhesive which can bond dissimilar surfaces and perform and provide a required performance at different levels in terms of strength and overall properties. So there are the range of chemistries which are available from epoxies, PU, MS, rubber, range of chemistries which provide the right solution to bond dissimilar substrate. It is clear that adhesive is not just bonding, but it is solution that transform the automotive industry from inside out. So this is in automotive OEM, we are there into weld shop products, paint shop products, and as well as assembly shop products. Weld shop products, we have mainly rubber and epoxies, a range of rubber-based products which are meant for reinforcement, structural adhesives, anti-flutter, and NVH products. There are a range of products are there, and as well as in case of epoxies, there are again, it is a very proven chemistry for especially where we need a strength with good toughness, that is also there nowadays with epoxy. In paint shop products, we have seam sealer, underbody coating, rocker panel coating, roof disc sealer, everything it is in the range. And as well as in assembly shop, all rubber-based products and room temperature curable products are available with us. I take you to some technologies which are we commercialized, and our customers are getting benefited with this. This is kind of preformed HDF, which is rubber-based product, and having a loss factor of say tan delta is from more than 0.6 at wide temperature range, starting from say 0 degree to 40 degrees Celsius. It is more than 0.6, and which is and it is a preform kind of thing. So this is really giving a very good noise reduction in a frequency range of 1 Hertz to 50 Hertz. Another, like we are also working on some new development activity, which is again the loss factor, you can see it is quite high, close to 1 or more than 1, and across wide temperature range starting from 0 to roughly 50 degrees Celsius, which is suitable as per our Indian climatic condition. Another one is like we have rubber-based anti-flutter as well as high damping foam. The previous one, what you have seen is, it is in preformed shape. This one is in pumpable form. In pumpable form, we always like, there is an issue from when the body passes through the PTET process, there is a lot of PT contamination due to wash off of the pumpable sealer. We provide a technology which is based on some fiber technology, and in the paste form, these fibers provide a very good wet strength, wet cohesive strength, and the product retains its shape even in the pumpable form, paste form. So this is, it improves the paint quality and reduces the sludge formation. This product is very it is low temperature curing, and we can adjust the expansion as per the requirement. Over and above, we also like anti-flutter and damping benefit. We can conventional mastic with good wash-off resistance, and anti-flutter and damping is good damping properties, or you can say anti-vibration properties. So this is kind of high damping foam kind of product, which is having a loss factor of more than 0.5 at any point of time, and conventional mastic is having something around 0.2. We are also there in structural adhesive apart from conventional mastic adhesive, conventional hemming adhesive. Structural adhesive provide a good energy absorption, and especially provide a structural integrity and stiffness, which is required for the body in case of any crash or any accident. This is really required. It absorbs the energy and helps to transform the energy from one part to another part of the body and reduce the localized impact. So that is, there it is having a very good, you can say that combination of strength and elongation. So that is there with structural adhesive. Very high impact peel, and strength properties are really, it is surpassing the specification available for the structural adhesive. For the paint shop sealers, there are a range of products like one is nowadays, as we all know, that reducing the oven temperatures or eliminating the ovens in the paint shop process to reduce, to make a smaller paint shop and to reduce the carbon dioxide emission during curing process. So we provided this technology like completely wet on wet. The important thing is here is this particular product, what we developed is, it is having a paint compatibility in monocoat paint system, which is similar to or better than the painting process, which is pre-gelled. So in case of even the wet condition, this is having an excellent paint compatibility in monocoat paint system. Otherwise, and we eliminated this completely sealer oven. Another very important factor nowadays, like we use some kind of vegetable oil based product and reduce the phthalate content into this one. Phthalate, we all know that it is a kind of some carcinogenic material, and of course, for all automotive OEMs, octyl phthalate is banned till octyl. Still nonyl phthalate is in use, but we reduce the phthalate content by almost 50%, and in turn it is helping us to improve the vehicle interior air quality, which knowingly, unknowingly we inhale when we sit inside the car. We inhale that kind of hazardous material. So that is also we reduced significantly in this particular technology. You can see a conventional PVC-based plastisol, like you can see the volatile organic content, which is there in any conventional plastisol, whereas reduced or we can eliminate phthalate content also. That also technology we are working as of now. So you can see that the VOC content is significantly down in the product which is based on the vegetable oil kind of thing. We are there to assembly shop which is based on rubber, different kind of rubbers we are using, and to provide again a sealing and the bonding application. So this, it is again based on the different specification like Hyundai or Mahindra, Tata, everyone we provide this kind of product. We are also there into adhesive segment, which is based on the epoxy chemistry, which is again bonding, sealing and coating application. And there are pre-applied epoxies and acrylic, which is again for the sealing and locking purpose. Anaerobic adhesives, which is acrylic-based anaerobic adhesives, cures without any in absence of oxygen. So that is there. Cyanoacrylates, MS and PU. So these are the product range available with us, which we can provide a solution for this one. Yeah. Thank you. Anything?
Yeah, if anybody has any questions that they would like to answer. Dr. Chen, Dr. Tian, sorry, please.
Okay, good evening, ladies and gentlemen. And first, I would like to thank you for taking your very precious, the Saturday night to come to have the, this interaction and communication with us. And also, I also like to thank you, our, close collaboration partner, Chembond, to host this, very exciting, the meetings, and thank you for that. Actually, this is my second time to be Indian. The first time is 16 years ago. I actually work with the Honeywell, and we have leadership, Asian Pacific leadership, training in Mumbai and India. And after this 16 years, I do feel the developing, the growing, and the crowdy, and the heat. Okay, all the kind of economy. So it's very exciting. So today, basically, I am only talking about besides the brief introduction of Darbond technology. So I will basically focus on some packaging material solution. It's more like for the EV, the adhesive for the lithium battery, the solutions based on focus on that one. So the EV is a very exciting, the opportunity has a huge growth potential. Today I just talked to Chembond, the managing director. In China, this year, China will produce 15 million EV automobile, 15 million, and which is only 50% of the total automobile they produced. So anyway, so the total automobile in China market is also 30 million. So, but EV is already penetrated all the automotive market over 50% already. So I do see there's a lot of potential growing in the Indian market. Okay, so again, I will just give you a brief introduction about Darbond technology. Then we'll talk about some, the understanding of the EV battery, and I will also introduce the EV battery adhesive product solution, which is not only the product, which is only focused on the adhesives, and briefly mention about some future outlooking or planning of the EV battery, and also what is our future production, the technology development focus. Okay, Darbond technology is established in 2003. Our headquarters is in Yantai, Shandong province. It's also a coast city, and it's located in Shandong Peninsula. It's a beautiful city, and basically we are producing the product called electronic packaging material, and this is all our product. This packaging material can use in IC, semiconductor IC chip packaging, and consumer electronics packaging, or the the PCB board, and something like the mobile phone, notebook, and TWS, everything the packaging applications, and also with the new energy area like EV, like the PV, photovoltaic, and also with some high-end equipment applications. Okay, the company again is located in Yantai City, Shandong Province, and we have over 700 million employees, and we have 7 production sites. We are the public listed company in the Shanghai stock market, and our headquarters is in Yantai, and we have a plant in Shenzhen, in the near Shanghai area called the Suzhou area. If you have been China, very close to Shanghai, and we do have a plant in west of Shanghai, west of China, in Chengdu city. And then we do have the international setup, and we have a Darbond International Headquarters holding company in Singapore. In Vietnam we have a technical service center, and then we are currently doing our Thailand the manufacture site, and we will have a Thailand operation beginning by the end of the year. Of course, we are looking for to set up our local manufacture site in India, and maybe pretty soon. Okay, as I just mentioned, our product can be used in the integrated circuit, packaging, consumer electronics, communication equipment, and new energy. And today we're going to talk about the EV and the lithium battery, and some transportation, advanced manufacturing. So this is our product used areas. Okay, so again, if we buy the definition, basically start from the wafer packaging, chip packaging. You had to use a lot of semiconductor packaging material. Then on the board, the PCB board, you have to use a lot of packaging material. The system, for example, like automobile, the EV automobile, and also the lithium battery, we consider that's a system packaging. So this kind of a definition basically including all our Darbond technology on the product. Okay, this is a solution company. We provide a series of product, a mini product. Well, this is just the examples. But today we will be focused on the one product line, which is more like for the lithium battery packaging adhesives. Okay, we are very technology focused, R&D focused company, and we have the R&D group and set up with our manufacturer site and our central R&D center will be close in the Shanghai area. So we have R&D center in Yantai and in Pensang and Suzhou and in the other area. Okay, again, I mentioned we are very also the innovative and focused on R&D. And one result is we do have a lot of innovative, the invention disclosure, and we have approved invention, the patent more than 300. Okay, this is our quality and environmental standard and all the kind of system certifications. Okay, now we talk about the EV battery and the adhesive for EV battery. Okay, we talk about the adhesive to design the adhesives for the EV, for the lithium battery. We have to consider these 4 key aspects. So first is the structure bonding. For the structure bonding, for the EV, for lithium battery, you have a different, the interface. So the adhesive has to have a very good adhesions to different interface. Of course, this adhesive has to have a high mechanical performance, the strength, especially some impact, the strength. And this is rapidly changing, the design, and you need to have a very rapid changing design and upgrading of the material for the different and the new generation of the EV lithium battery. And this adhesive has to have very good electrical performance, which is including the breakdown voltage and the volume resistivity and surface resistivity and sometimes insulations. And also the process, manufacture process, you has to be very flexible. Different, the company, different, the customer has different, variation of the process. You do need to have this material, have those kind of flexibility. Then second one is the thermal conductivity and insulation. Sometimes you need to have a thermal conductivity. Sometimes you need to have a very good insulation, especially in a very cold area. You want to have some insulation to keep the battery not cool down so fast. Okay, so in this area, you need to have overall high thermal conductivity efficiency. What time I have here? I want to control a little bit. It's okay, you remind me. So secondly, balancing thermal conductivity and mechanical property. Sometimes this kind of adhesive, if you do some, you consider some thermal conductivity, you put a lot of the conductive filler in, you will sacrifice some the mechanical property. So that's some challenges, some balancing you have to do. And the balancing the thermal conductivity and the process. Again, if you put a lot of the filler or whatever into the material, you probably will affect the viscosity and the flow property, and which probably you will affect the process. These are another challenge. So right now we are talking about we need to have a high flow and high volume dispensing of this kind of adhesive, increasing the production efficiency and increasing the production speed. The third one is the process flexibility. And we are the first one in the world to develop this 1-to-1 ratio. This is a 2-part. The majority, one important adhesive is a 2-part polyurethane. So this 1-to-1 ratio used to be before is a 10-to-3 or whatever, 2-to-1. The 1-to-1 ratio is the start from us, and this is we call this the golden ratio. This make your process and the control and very easy and actually visible. A different color I will mention later. You will have the material needed to have excellent clamping strength, and then you can move to the next the working station. assembling friendlies. Okay, so you have a different processability. So the last one, we consider this material. The material is the important portion of the overall the lithium battery pack reliability. You will consider the material reliability, assembly reliability, process tolerance, process window, and also equipment friendliness. Okay, this is more talking about the for equipment the wear resistivity. Normally the equipment has to be maintenance in 1 month and 2 months. You don't want this adhesive and also process make you the equipment the wear too fast, something like that. Okay, in here we're talking about the two kind of battery. One is a power battery for the EV. Another one is a storage battery for the storage station. Also the lithium battery. Also you can have a small lithium battery for the consumer electronics, and we also have a series of material for that. Like for example, like a mobile phone, the lithium battery. In here we just talk about this power battery and the storage battery. So for the power battery, you have to consider some well seam sealing, and the module position, and quick fixing, and the thermal interface management. All these are considered in the materials, adhesive, repairable sealings, which sometimes you have to, when you're doing the process, you have to repair, you have to tear down and repair. You have to consider this adhesive has those kinds of properties. Then thread locking, UV insulating coating for some protection, the pack sealing. After the packing, you have the sealing to do, foam sealing. Then this is important is the structure bonding. Other, the consideration tap, the positioning, protection, cell protection, component, which is module sealing, reinforced ring sealing, and then another class of the material is both has structure bonding and thermal conductivity. So we call thermal conductive structure bonding. And for the storage battery, you have a similar requirement. You have structure bonding and also thermal conductive structure bonding. Okay, so this is in summary. This is a six area we have to consider. First is this is the lithium battery pack, and first is two-part PU thermal conductive structure adhesive. Secondary is a PU high strength. This is more talking about structure bonding, structure adhesive. Then we need to consider about low density fitting of adhesive. You want the lower weight. Okay. So the fourth one is a low density parting material, low viscosity parting structure adhesive. Sometimes the dispensing, the thermal conductive material, the viscosity can be higher. You have to balancing that, the viscosity. Then you have a CCS and FFC protection adhesive. Okay, this is in summary. This is the sixth aspect. Okay, now we go to a little bit of detail the product introduction. So again, the category is one is the thermal conductive structure bonding. Another one is the sealing. Doing the pack, you do a lot of sealing. So for the thermal conductive structure bonding, you also have three types. One is the structure adhesive. One is the thermal conductive structure adhesive. And then you have sealing and bonding, double functions. For the sealing, it's just a sealing functions. So for the application, for example, the structure adhesive. So we have considered some quick positioning. You have fixed area adhesive coating. If you're dispensing the material after the press, you don't want the material actually bleeding out. You want the material can hold in the area you just dispensing. So you have to consider the balancing of the viscosity and also thixotropic properties. Now the material we are doing is a quick high flow, high volume. We call the scrapping dispensing. I don't know if this English is right or not. It's just a quick, high volume, quick, fast dispensing. And then this is a high performance. For the thermal conductive structure adhesive, so you have a different thermal conductivity coefficient. For cake dispensing, sometimes, especially like a Tesla, you have a side, the plate. This plate is 45-degree tilt doing the dispensing. And also you want this material after dispensing, you have the gap between the dispensing line. You want the material can flow to cover the line, the gap between the line. So this is called the leveling flow, and which actually is the material property of the balancing of the viscosity and the thixotropic, the combination. So this has to be considered in the adhesive design. For the sealing and the bonding, for some reinforcing and sealing and parting. So this is on the third, the column, you can see for those kind of different function, then we have a different, the material recommendation. For the different material, then you can use in the different point, different location during the process. For example, PET blue film. If you are doing the packaging, you are the engineer, you're probably familiar with that. And aluminum alloy different, electrophormetic aluminum, and spray. This is more like a spray coating, and forming resin, and aluminum plastic film, ABS and PC or whatever. You do have those kind of the point has to contact with the adhesives. For the thermal conductive structure adhesive, you have to use in the aluminum, also electrophoretic, steel, and aluminum, and also you have to contact with some spray coatings. Then for the reinforced sealing parting, you have to use the thermocouple protection, connector protection, blue film sealing, and the sealing and bondings. Okay, so sealing is more like these three materials. We talk about thermal structure bonding and the thermal conductive and the structure bonding, which is more like a two-part PU with a different, the thermal conductivity. For the sealing, is more like use the silicone. Okay, so this is really give some the example of the module and the structure, and where is the material used. For example, like the top cover and the side plate and the end plate, and also the between the cell. Those kind of area you have to use different the material. The thermally structure only, or the parting or sealing, and we have the different material recommendation here. And this is more like the VBA the module. We call the CTM C2M module. This is more like the previous generation. I think the important is they have the side plate. And the most recent, the design is they don't use the side plate, and they are using the steel, the belt, to actually to pack the different cell into a module. So this one is much simpler and use less, component, and also the assembly is high efficient and also very it's much fast. Okay. The line is shorter. So this is we have all the material recommendation for the different, the point of applications. So basically, we are the solution provider. We can provide all the different adhesive and the packaging, material for the lithium battery package. So this is the full plate. This is on the bottom the full plate, and also we have some the material recommendation. For example, like the thermal conductive bonding at the bottom of the battery pack, and the sealing of the shell, seal. Okay, this talk about VDA module, structure adhesive. We thought that this is C2M, the structure. This is more like the one I just mentioned. This is the previous, the design with the side plate. I think this is the flow of the process. The station 1 is the plasma treatment of the cell surface. The station 2 is the plasma treatment to the side panel. The station 3 is the cell dispensing the adhesive to the cell. The 4th is the dispensing of the adhesive to the side panel. Then the assembling position, then the side panel welding, side panel heating, then cooling. So we do have some the material. Probably that's a bit. The features, this material, you need to have a low density, low modulus. What kind of property, what kind of advantage give you low density, give you low weight. Low modulus give you some impact resistivity. And inorganic failure give you some, the thermal conductivity. And composite polyol design, this gives you some balance of the property, flexibility and also modulus. And the 3-color design, this is the 3-color design. So you have yellow color and you have blue color. This is a 2-part PU. Then you mixing and a product. If you have a completely homogeneous mixing, you will have a homogeneous green color. If you have a mixing is not homogeneous, you can clearly find out from the color change. So this is 3-color. This is very visible. And the thixotropy, which depends on what kind of applications. It's a side plate or it's a bottom, it's a full plate. And then you have a wide proportion tolerance and low viscosity, and also to give you some, the advantages of from the process and the benefit, and all these kind of features give you some benefit. So I don't want to go through all the kind of detail here. So we do have a recommended product for the product. This is used in the lithium battery for many very high volume already. And we are the dominant. I believe we are the leading market share in this whole EV lithium battery. The market share. Actually, we are producing the 40,000 tons this year. In China, basically top 10, all the lithium battery for the EV battery for the EV cars, all these top 10 the lithium battery manufacturer are our customers. So they have been used this material. Some material has been used for more than 5 years, 6 years, almost 10 years. So this is a recommendation product. The color we are using the very all using this 3-color the material, density, viscosity, and strength, and operation time, clamping strength. Once you clamping the side plate to making the module, you want to have a very short time. They can reach the 0.015 to 0.3 megapascal. Then you can actually you have some strength that you can move to the next station. Allocation and also some 1,000 aging test. This is all depend on the customer's request and the process the needs. Okay, so this is demonstrated two different the VDA module. One is the module with the side panel. Okay, as I mentioned, this is more like a previous the design. And this design actually, the product line is longer, use more component, and the efficiency is low. And also, this is heavy. So you're talking about density, energy density. This is heavy. So this one is most recent, the design. This is a module without the side panel. Without side panel, they use some belt, steel belt, to hold the all lithium the cells. And this one again, the product line is shorter, the component is less, and the efficiency is higher, and you know, the energy density is higher. Okay, so this slide is demonstrated that there's two designs. One design, you have the not fully covered in this side, in this area. So you have, we call the open window. This is aluminum. Okay, this one they can actually increase in the adhesion strength with this surface with the you know, the side plate. This design is a CATL, which is a leading company in the world of lithium battery for EV. And this kind of design is fully covered. They use this blue film fully covered, and then the adhesion strength with this side with the side plate is low. But anyway, two designs have different merits and the different advantage and disadvantage. It all depends on the design. And this one talking about why we have to use some adhesive for the when you connect the cell to the side panel, because when you finish the module, if you want to lift in the module to the next station, when you lift this kind of cell, if you don't hold very well, and the cell will drop like this. Okay, this is the more like the little bit old, you know, the process. This is called a manual process. You don't need to have this kind of adhesive to hold the, you know, all the cells in same level. But the automatic, you know, the process, they don't need this kind of adhesive because they do have, you know, the bottom support. Okay, so they will overcome this kind of issues. So we need to have, you know, those kind of adhesive. And especially with the module size become bigger and bigger, heavier and heavier, this is kind of a problem. You have to use adhesive with the side panel to overcome this problem. Okay, so the process parameters, you can select the operation time 5 to 50 minutes module based on the module size, and we can recommend the 2117S for these kind of applications. If the module is larger, then we need some heat room temperature to heat the, you know, the side panel to make that material cooled to have a better strength to move into next station. So the dispensing the material, you can use a different way to dispensing. This is N type, this is 3-line, and this is a circle type dispensing. They all used in the different companies. Okay, so so this is for the side panel. Also, you have a this is called dispensing pattern between the cell and the side panel. This is so this is one kind of design. This design is associated with that. As you remember, I talked about there's one you have you know, not fully covered. Okay, this is a CATL design in this kind of dispensing the fluid. And this is the other company, they use this kind of dispensing pattern. And also the recommended, you know, the material for these applications. This is just some, you know, the shows, the video shows. And this is the first. This is plasma treatment, and this is dispensing of the material. And this picture is basically assembling the different cell into the module and also moving the module to the next station. Okay, so these are talking about C2P, the cell to package in the pack, bottom liquid cooling plate bonding. And also, we have the detail. I don't want to go to each detail. You know, if you have an application, you have questions, we can give you all the kind of detailed recommendations. For example, for these material features, what kind of feature give the advantage, the advantage give you some benefits of the packaging. Then we do have you know, the different the material recommendation listed here is the material, the important material parameter and the properties. Also, this is for this cooling plate bonding has a 3 stations. Station 1 is box processing packaging, and this is dispensing and module positioning and assembling, and then final assembly in the position. Okay, so this is for the C2P pack thermal conductive structure adhesive. Okay, so this is 3 types of the design and the structure. These 2 pictures shows the one. This module is placed in a pack with the bolt fixing. So after applying the dispensing the adhesive, it can be lifted and fixed with bolt. So this is one thing. They use the thermal conductivity range from 0.8 watts to 1.2 watts. Okay, this is a different one with the cooling plates. This is the low module design called the C2P. This one you can consider we call the C2M, cell to the module. Then this one has no module, basically. This is called the no module design C2P, cell to package. And the battery cells are placed in the pack, and the horizontal and the vertical beams as the side panel. The thermal conductivity range is 0.38 watts to the 1.2 watt, depending on the different customer, different design. And this is the most recent design. This is the latest module design, and the battery cells are basically directly placed in the pack directly. So this one you have to more depend on the structure adhesive to give you the strength and the reliability. Okay, so this is the latest design. So the material we recommended, you know, the thermal conductivity range is also similar as this one. Okay, this one show you the dispensing the pattern, the revolution. In the previous time, you like more like dispensing the material in a very thick and the line dispensing. Then you become kind of more like a flat, and evolved to the most recently you used some like a printing kind of fast white dispensing pattern, and this is much fast and much efficient. And with this kind of revolution, the material viscosity and the thick soft property has to be balancing, has to be checked. Okay, this one is not popular. This 4680 is not popular in China. Even Tesla. Tesla's the lithium battery, the EV car made in China, not using this kind of pack. They are using the CATL pack, which is not a cylinder, which is those kind of shape. Okay. So with this one, we also have the material for this application. If you using this kind of design, so we also have a material recommendation like parting compound, the extremely ear protection adhesives. We do have a recommendation: thermal conductive, silicone gel, structure adhesive, and thermal insulation filler, and also structure adhesive. So this is the detailed material recommendation, and some material recommended material property parameters. For example, this is the PU. This is the adhesive. This is the foam. PU foam adhesive. You know, the 4680 they use the foam to do the parting. And they also use a lot of use a different silicone. Okay, so basically I just go through some adhesive application for the EV lithium battery. Last 2 slides I like to briefly mention, but my time is okay. Okay, so this is we talk about global automotive. You know, the packaging, the EV battery, the module and the pack product requirement. The trend for the automotive, you know, the development trend is you need to have a wide temperature range for this battery, because you have to suitable to drive the car in an extremely cold area, also in some extremely hot area. Okay, so you need to expand the temperature range. And in order to give you some more power, the module and the pack become the larger size. Actually, for the structure bonding, the design and also the adhesive property is a challenge. You need to come out with the new, stronger, the material. Okay. So also we're talking about the fast charging. So you have a 4C fast charging, 50 minutes charge. The full charge. So this we call the 4C, and this also some material adhesive can help. And it's extremely cold and the hot area, we just mentioned, and complex road condition. And this is also you need to improve the light weighting. Lighting, you have increase your energy density and highly integration. Okay, all those kind of the property integrated into the next generation battery. So the material answer, material solution, material development design is currently the most advanced popular material we call the hybrid material, which is the epoxy and mixing with the silicon with the MS, silicon with the PU and the silicon hybrid polymer. So basically, you have a chemistry modification, silicon and PU. Then you have a physical mixing with epoxy. So basically, this material have a balancing of all the advantage. You have an epoxy advantage, you have PU advantage, and you have a silicon advantage. And this actual material will be used in the next generation of the EV lithium battery. It already has been used, has been used in the CATL and BYD. And the low modules give you some, the higher impact resistivity, and high strength give you some, the maybe complex road condition, give you those kind of property. Higher elongation give you a material more like a flexible. The strength, impact strength is higher. Low viscosity parting give you some, the process advantages. Then heat prevention and insulation, low density, light weighting also can give you some, the advantages for those kind of trend. Okay. Okay. So also we also developing some, the material for the different the battery, the solution like a hydrogen fuel cell, and we are also developing some material for the hydrogen the fuel cell, the packaging, and also for this sodium ion battery. You already noticed that the CATL and other company already come out with the sodium ion battery. This is much safer, and although solid state is also coming very very soon, which need to have a different adhesive, and you need to come out with different material answers. Okay, for Darbond, as I mentioned, okay, we are the leader of the market share for this lithium EV lithium battery adhesive solutions, and so we have been in this market for more than 10 years. Started from a very early generation of the lithium battery, and technical strength. We can with commercialization of a low modulus PU material, multi-type of product, UV, PUR, MMA, silicon, parting, sealing, structure, and also thermal conductive. Participate in developing industry standard. We also create some industry standard for the market. And also the other, the advantage is the product line. We have a full the product line, and we have a solution for the EV battery, for the storage battery, and also consumer electronics batteries. The entire automotive industry chain. So assembly, ADAS, powertrain, and Dr. Eugene, she will talk about a little bit about that. And fuel cell, solid state battery, and also performance advantage. So our material can address low density, light weighting, hybrid system, no modules, high strength operation time. You can have a variation, wider the process window, and also high, medium, and low thermal conductivity. So all the kind of properties. Basically, this is my presentation today, and thank you for your time, for your attention.
It's my privilege to represent Darbond to talk about the thermal interface materials specific applications in the electric vehicles. Next. This is my talk. First, I give some leverage here for the introduction, then talk about briefly go through the Darbond thermal interface materials product. Then we can spend a little more time in the application to find opportunity for our materials in your application. Then we talk about the next generation teams. Then because most of the automobile electronics thermal solutions come from semiconductor industry. So then we can look at the trend. Okay, I will try to speed up a little bit. As we know, we have the 5 domain, electric or electronic domain in the electrical vehicle. The first one, the drive, side, we call it the cockpit. We have the controller, display, the heater, and so on. And also, Dr. Chen already mentioned the ADAS, right? It's similar to the consumer electronics. I think the most important for the EV is the powertrain. He already mentioned, then I'm going to talk about a little bit here. We have the motor control unit, inverter, the battery management system, and converter. And most importantly is IGBT and MOSFET. This is go to the power semiconductor. Okay. Then we have the usual the body, right? The chassis. I'm not spending too much time on it. Currently, as you guys in the EV industry, you know better. Currently, everything is integrated, right? First, we have so many electronic control units. Right now, we become domain control unit, right? So we just said we have 5 domains here, but this trend is still continue, right? We're going to further integrate it to the centralized computing platform. Maybe later on in your, the EV, you need just one centralized platform. That would be future. And also, Darbond follow up this industry from beginning until now. Pretty much, we have most of, I should say, the performance cost effect solution for you. Okay. Here is our trend in the EVs. Sometimes called power electronics. You get the ACs from the grid, right? Then through onboard charger, changing the AC to the DC to charge the battery, right? This is Dr. Chen just talked about it. It's a battery pack. Then, if you have the fast charge killer, you can charge it directly through the battery management system. Then this is the high voltage, the battery power, right? The first you change the the 400 or 800 volts to directly to the truck motor. Use the inverter. Use the EV brand. The brand, the inverter. Then to drive the vehicle. And right now, because the technology advanced, you already become bi-directional. So, for example, if you in your EV you break your vehicle, this stator and rotor is going to continue generate ACs and charge your battery. Okay, and also you can eventually you can put your electricity go back to the grid. That's the most of the advanced technology, and also here because all this power, right, generate the heat. So the heat, this is the heat we have to manage it pretty well. Otherwise, it's going to impact your performance.
and also the safety, the most important safety, and also, of course, your components life span. The solution is we put the thermal interface materials in between the cold plate and hard plate. That's why they call it thermal interface, right? Between these two interfaces. And the distance between these two interfaces is called a bond line thickness, short BLT. And also the thermal resistance between the interface, the contact resistance we call the RAC. This depends on your soft and how well your materials weighting with your surface and so on. Okay, this page is talk about the key application requirement of the thermal interface materials in EVs. For example, the battery pack is the most important part and the most critical part, and Dr. Chen already spent last an hour. I'm not going to talk about it. Second one is called the electrical motor. For all the thermal interface materials, obviously you need the high thermal conductivity, right? But some additions. When I was thinking about when first I was a student in the U.S. We changing the oil filter. If you look at the power, the parking lot, you always see the oil stain, right? So that means oil is leaking, and also the coolant is leaking. So your thermal interface materials is going to have chemical resistance to this fluid, right? And also the motor always have the highest vibration, shocking vibration, right? Your materials have extended that, right? This obviously give the requirement for this part, right? But most importantly, actually, is powertrain. We call it power electronics. And also there is some we call the automobile electronic domain. No matter what, it's basically to transfer the semiconductor die, get the heat from the die itself or from module itself to the cold plate. This is a very high demand area for thermal transfer in the EVs. Maybe the highest. Usually we need a thermal conductivity between 3 to 15 watts per meter K, right? And then you need the lowest thermal resistance as other semiconductor die, right? And also, of course, you need high reliability. You cannot say, I need a break. My electronics doesn't work, right? There will be a safety issue, right? So the power electronics for IGBT or silicon carbide MOSFET is very important. It generates instant heat in a very small amount of the area. We have to manage that. So this is the common type of the thermal interface materials used. For example, the pad. The one, never you have the gap larger than 300 or 200, you use the pad. That's first generation. And also, later on, you can use the liquid because there's more conformity. Because this is a pad, usually it's cute elastomer. You have the high contact resistance, right? So these have the advantage. That's why you, especially for the different stack height, you use the liquid have more conformity. And this is we usually generally say that this is a gap filler. These two are gap filler. These two, phase change and the thermal grease, usually is used for the semiconductor die. Semiconductor die, yes. First one is phase changing materials. We have it is solid at room temperature. When you use it, it becomes a liquid. Okay, have very lower contact resistance, and also you have it is a problem. It's pump out, the dry out. We're going to talk about our Darbond solution, and also the thermal grease is also the first generation used in any semiconductor industry, and also in the power module in the automobiles as well. So then it's used a higher performance power module. Okay, so and also it has its own problem. For example, also the dry out or the pump out, especially for the larger die, the larger chips. Okay. Then the last one, you need the semiconductor adhesive, whether it's epoxy, polyurethane, and also some silicones. You need a mechanical strength. Also have the conductivity requirement. Then you just dispense it. It's a little simple. But the trend right now, because whether it's the semiconductor industry or the automobile industry, it needs some more, some solution. They develop new materials like, the liquid metal. I think we have some sample here as well, and also graphene. Also, somebody even use a diamond for the transfer for the future. That's the general requirement. And as Dr. Chen already said, what we can provide, we have two subsidiaries. One is in Shenzhen, fully focus on the some interface materials, and this one is focus on the telecom, like Nokia, Huawei, Samsung, Ericsson is our key customer for this one. This one, Suzhou, is Takino. We just acquired not a long time ago, and they focus on the AI data center. So, but there is some very complementary, product, but there is some similarity as well. Okay, this is a portfolio we provide. Basically, the gap filler, as I mentioned, the silicon or non-silicon, because the silicon elastomer always have the high contact resistance. You need a softer materials. That's why we provide the putty. Putty, you can put the putty itself, you can put the putty pad, right? And you need some carrier. You can use the polyimide carrier. And also for the gap filler, for liquid one, we have the one component, pre-cured or one post-cured. Post-cured is for the Tian 1, for the semiconductor industry. We use it pretty often because it's much more expensive. The two component cured, usually called cure-in-place gel, right? This is for gap filler. Then we talk about the thermal grease. Thermal grease, because of pump out, large pump out, then what we do is cross-link it about 15%. So prevent is pump out for the large die. The larger die because you have the more pump ratio. And also phase changing materials, what we do is, this is because the liquid is pump out. Then why can we reduce the liquid behavior? We put some plastic in it. So we gradually change the viscosity and become the paste. So, and also liquid metal, and this is semiconductor Tian 1 and Tian 1.5, and also the carbon-based. Right now it's very popular. NVIDIA uses graphene, and also we are keeping up. And also the other one is the EMR sharing, because it's closely related. So the gasket, and we can do the thermal and the EMI absorption, and also some foaming place, the adhesives as well. Lastly, we can do the semiconductor one, obviously. Electrical one, we can do the insulator, right? Whether it's thermal or the electrical. And also we have some niche product, like the pluggable materials. If you use in the 5G module or the optical module, and also have some energy storage materials. If you guys are interested, this is what we use in the medical industry for the ultrasonic, equipment, and so on. Bottom line, I think the Darbond has the full range of thermal solution from the Tian 1.5, and also from component level to the board level to system level, and also for the different industry, and also to fit in your need. We can do the die cutting, pick in place, or the printing, or and so on. Okay, that's it. Then we talk about as I said, the pad is the most mature one, right? Because we segmented so many products. Here, we call it the gap pad general series. So using the gap pad, you know, is as I said, you know, about the thickness about the gap height is about 200 or 300 micron, right? Usually we say the half millimeter. And then if you look at the hardness, it's about 40, 50 or some little less. And also some conductivity from 1.5 to 5, right? So this is one series, and then another series is on the graphic. We can provide the semiconductor from 2 to 13, and also the conductivity from 40 to 60. Okay, this is because these two companies substitute. Yes, you are doing right. You know, because there is so many requirements from this area, we have developed ultra soft series. And also, if you look at ultra soft, if you look at hardness, you know, it's much lower, could lower as a 20 or even 30 something. That's flash. Next page. Oh, I just do it. It's too fast. Okay. When you need some pick and place, you know, the capability, we can specifically design, have some feature, and also mechanic strength for you easy to pick and place, right? To increase your productivity, and also steam. If you have some application, you know, we can design for the 200 micron series, low volatile, okay, and silicon free. If you have some specific applications, especially in the optical industry, you know, there's no silicon here, and also the total, you know, material loss is 0.0, and the previous is even lower. And also insulation series, and also this is if your application need a lower dielectric constant series, and we have this product. And please press that button to go back. So, and you know, this is party. You know, if you look at party, the hardness is only 10. Very low contact resistance. Okay, very low. Okay, and because I go through the pad, the general theory and the segmentation. Here I will only talk about it. You know, the general series. If you have a specific need, let me know. Because in second of time, I won't talk about it. Here, if you look at one component, usually we talk about pre-Q. Pre-Q is a little bit easy, cost-effective for many applications because you don't need to handle the you know, the low temperature, you know, transportation and also the curing at your application place, right? So. If you look at the semiconductivity, it's also very compatible from 3.5 to 12. Okay, and this is another serial from 2 to 12. And this is two component general serial, and this is the semiconductive from 2 to 12, and also the ratio is 1 to 1. This is another series, you know, look at, and we provide some non-silicon one, you know, for the specific application, one component or two component, and also the reworkable. For some application, you need reworkable materials we have, and also this insulator, and also here I want to pause a little bit here because this is one of our, actually most popular product used in the semiconductor industry, phase changing materials. We have the phase changing materials. Usually we have carrier. Here our semiconductivity is about 2 to 4 on this page. Usually you have the carrier, easier to process, easy to handle. Next page, then we have the a little bit high. Semiconductor could high as 9 per watt per meter K. So, but you have to use the solvent printing. but some of our customers like this, especially for minor, the computing, okay, industry. This is another series of phase change. And as we said, phase change have some issues. Then we put the thermoplastic materials. If you guys are interested, especially you use a larger die. And then we have some performance comparison underneath. We can discuss another level of details. And the thermal grease, right? Use the higher, the performance thermal module, right? Power module. So we have all this, grade from the semiconductivity from 2.8 to the 5.5. This is for the 6, okay? And this last one I will talk about the plug-in materials, just like this. We put the thermal phase change materials on the polyimide or the stainless steel. We can easily transfer some thermals. And then we talk about EVs. EVs, this portion, I think you spent the last hour with Dr. Chen to talk about this. I'm not going to talk about it. I'm talking about the chips, the underfill, the TFM for the computing, for the coating, and for the thermal pad, and so on. Okay, this is we call it the electronics. And also you have some fixing, like you use the silicone. Is our product. This you have some epoxy. We have all this product here. And this is a onboard charger. Onboard charger. Obviously, your first thing is you want to seal it as a component, right? And you have some strip, rubber strip for the EMI sharing. For the specific content, there is a lot of chips there. For each component, you can use the thermal gel or thermal pad. And here you have a connector, and also you have another chips here, okay? And this is a brain for the the EVs, right? The controller. So again, the sealer, the shell sealing. We have the foam in place gel or Q in place. Then more recently, we developed some UV Q in place one. And all this is the IGBT, the most of power generator, the heat generator. And then obviously you have to fix it, and also we have a lot of the thermal material solution here to match your need. And also this is a DC to AC converter, right? You have the big thick casing here. Obviously you have the PCB, the board, and have the controller, and a lot of thermal solution or adhesive here. This is an inverter. What it look like? And the PC, obviously the seal. We have the 3 materials we come on, and also we have the water core seal, and also a shear infiltration and connector as well. And this is a DC converter. This is very important. You cannot break. Otherwise, you have to lose the EV control. Anyway, this is shell, similar, design. You have the shell seal and connector. This is a PCB. This is thermal grease or the pad or even gel you use. This is Adhesive. Adhesive, if you look at how many die on it, right? So many die. Each die has a different height, right? Then it's easy for you to use a gel, right? You can compensate. So that's why we recommend, the Q in place. The first one is 8 watts. The second one is 10 watts to place on the die. Then you put the heater pipe. Okay. And this is cockpit. The design. It's look like we have so many modules here. We use the 8 watts. Phase change materials and all the 8 watts as solvent printing the solution as well. And this is water heater. This is the single unit water heater. We have some polyimide, the carrier, the materials here as well. And also this is old fashioned. You just put a pad here. And the bottom line, this is summary. Bottom line, we have 2 substitutes companies to supply all the thermal interface materials. We think we can provide almost every application in the UV. If you cannot find it, let's wait. I'm going to talk about the next generation. If we in our pipeline, development pipeline, if we don't have it, we can co-develop with you. We are very confident in our R&D capability. Okay? This is a principle. We develop our thermal interface materials. From the physical theory, from random to random disorder to order, you can conduct the thermal faster, right? So you can do the first you put the filler into the polymetric is isotropic. Then you become anisotropic, right? And then you cover your line. Then you go to the Z direction line. There's a lot of the research on the paper you can publish, right? That's one dimension. The second dimension is from the material side, from the tradition to the innovation. This portion, if you look at the poor semiconductor, well, it's good. The semiconductor. This is the electrical conductor with poor, but the semiconductor is good. This is usually ceramic. We just generally say ceramic. But the polymer usually is poor semiconductor and also poor electric conductive. But in both cases, as we know, sometimes we need high thermal, but it's insulation, right? That means the electrical poor. So we concentrate on this area. But if you look at this area, is kind of metal. You can go to the both conductive thermal or electrical one. And on the other hand, you can do some phase change as well. So basically, you want to go from the single performance materials to the multiple function materials as well. So then, first thing is we have to look at matrix, right? The polymer matrix. You go to this is a list, and then we know that low K is the bottleneck for the high performance team. Because the random disorder of the polymer chain. Then we go to the regional, the polymer. Okay, put a line polymer. There's a lot of research on this one. Some even go to the thermal electric conductive or thermoconductive polymer, right? Conjugated polymer and so on. There's a lot of research here. Then the next portion is the high K filler. Most of the research we do a lot of research on the boron nitride. The 2-dimension. If you look at the regular book graphite, it's could go to 1,000 watts per meter K. Then if you go to graphene, a line, then you can go to 6,000. Right now we talk about 5 or even 3 or even the highest is 10 in the polymer industry, right? We still have a lot of potential there. That's why every idea is how to do the carbon nanotube graphene and even the isotope, the papers, published in the Nature or Science. Okay, and another dimension we use the liquid metal. Liquid metal we usually use the indium and bismuth. And right now, actually in our area, we concentrate on gallium. We can use it as a thermal interface materials, also heat conductive fluid as well. And also we talk about 3D. We'll put it in the carbon fiber, in the copper matrix, and then put it in epoxy. And also this one is alumina with graphene in a two-phase. One is like the cloth, and the other one like ball, and so on. There is some research here. And also here is vertical alignment and so on. But that's for the literature, for science. Here, what is in our pipeline is the next generation. One thing is we concentrate on the magic and fillers suspension. We find out if this random for the same system, the maximum thermal conductivity you can go only 30. If you can space it out for the filler, 200 nanometer, you can go to 300. That's 10 times. So we do some preliminary, research and so on. We have some product, research here, and it's not mature yet. is in our pipeline. Another one is phase change. We already have some reliability tests as well. And if you guys are interested, some of your customers interested, we can talk about it. And also liquid metal. This is bismuth, this is India, and this is gallium, India, and tin. This is we put it in the polymer as well. But if you look at this is for the 80, if we put the polymer, it's become 8. Right? This is we trying to do some research. Bottom line, we have to develop some product we can use, right? And this is our roadmap. Obviously, we concentrate on AI data center and server, and for the oriented graphene or the pad, and also the liquid metal and so on. And then we apply this in the IC package. That's the most one. Then we go to the high-end consumer electronics, and including automobile industry as well. And because, as I mentioned, most of the demand solution is from the semiconductor. Then I'm just briefly talking about the semiconductor product Darbond can offer. Wafer level and chip level. We have the 8 or 9 product. The first one is a wafer thinning tape. You need especially you have stock die, you need a thinning, and each die you need a dicing. And we have underfill, the chip level underfill. I know here a lot of people ask the ball level, but we have chip level for the die itself. Chip level team, I already mentioned team 1 called the team level, and also sealant, and also die attach for the old wire bonding, the paste, the film, and the conductive, the film. And also we have some board level support for all this. This further illustrate what I'm talking about. The wafer thinning tapes, just like this, and also the dyeing tape. And also this is a chip. Between the chip and the substrate, this is first level underfill, and this is the sealant. And until between the die and the heatsink, we have the team 1, and we have team 2 here as well. And as I mentioned, for the wire bonding, we have die attach paste. Then if we have the many stacks, we have the die attach film. Okay, for the memories. This is right now actually is pretty hard because the demand in the AI industry as well. Especially in the memory. And eventually, as I said, the automobile could borrow some solution or other solution from the semiconductor industry. So this is the current GPU CPU design for this called flip chip. This is first level underfill. That's the first level team, and also second level team, and also Adhesive. This is a kind of full product we have. This is server. So you have the thermal pad for the solid state, the driver, and also the graphic card, and also some other IC, heat dissipation, and also you need the main chip. You can easily use the thermal grease or the liquid metal. And this is a solid state. It's a device. This is a basic memory. It's workable and low volatile gap filler, and also obviously the underfill, and also gap filler. As long as you have chips, you need this. Okay. And also this is an old-fashioned power supply. We will provide full kind of materials as well. And this is we call it the broader semiconductor. It's also called inverter, photovoltaic inverter. It's similar. It's a lot of things we use: the thermal grease, thermal gel, and thermal encapsulant, and also pad as well. And this is optic module. It's a little bit broader, and also EMI, and also etc. Low volatile, because there is a lot of optics here. This is a communication base station. There is a lot of applications here in the thermals, EMI and the gel and so on. I think this is my last slide. I think what I want to use this to emphasize, Darbond want to provide a one-stop shop for our customers. Okay, two sense. One is we have so many products in the adhesives, so we can provide. There is a lot of sometimes there's a lot of interaction between the materials, right? You choose the one materials from one product, one company, you choose another one. Sometimes they don't work well, right? Right now we have the total solution from the one sense. The other one we have the very capable R&D and also good manufacturing, and also the high quality, and also the post-service sales service as well. So we provide the one-stop shop for you. If you have, and that's conclude my talk. And if you have any question, I know it's pretty fast. Then we can talk about after during the dinner or after dinner. Okay? Thank you.
Thank you, Dr. Eugene. So that was a very quick rundown of all the products that Darbond has to offer, and I think we're very fortunate to have both Dr. Eugene and Dr. Tim come here all the way from China. So thank you so much. Also want to thank Roger, who organized this entire kind of meet, who wanted this seminar so that he can bring Darbond's offerings to the Indian customers, and of course all the customers that we have over here. Thank you so much for coming all the way. Those of you who came from outside of Pune, those of you who came even from Pune. I know the traffic was pretty bad on Saturday night, but all made it, so thank you so much. And also thank you for standing, waiting outside while the hammering was going on and the display was being set up and everything. We just want to assure you that our technical capabilities, our customer service is much better than whatever the seminar setup was. Okay, so just want to end on that note. Dinner and drinks are served outside, so please help yourself. Oh yeah, and if anybody has any questions, you want to, can somebody pass the mic?
Yeah, I'm Hyatt from Mahindra. The presentation was very excellent. So thanks to both of you. And it was a very quality presentation. I have a few questions, not one question. There are many questions for me. How many of the companies produce such chemicals in China as on today?
How many companies doing those kind of the adhesive? This is a very hard area, a lot of opportunities. So many companies actually try to get into this kind of area.
Yeah. My question is that when you are saying that $200 million is your turnover, in top 10 you are saying that you are in top 10. So
correct. Top 10. I mentioned top 10 is they are doing the lithium battery. Battery company. That's what
I'm talking about
our customer. But for adhesive, for the specifically adhesive for the lithium battery, we are number one.
Oh, I think we are number one, but we got to the market verification anyway. We are confident because I think that the lithium battery right now most of the lithium battery produced in China. So we know that. Okay, so then we know the CATL. So CATL we have more than 50%, 60% market share, and we all know those kind of lithium battery companies are born. So if you ask how many companies doing this kind of the adhesives in China, I would say that if the decent volume, there's a visible volume, probably also there's more than 10 companies, something like 10, probably is the right number.
Yeah. And the third, USL, the Darbond, from your product portfolio point of view, then the other company.
Product with our competitor, right? So as I mentioned, we have been working for this. We understand this lithium battery requirement and evolution and the future trend, and we are working with the top end of the lithium battery company. Understand that. So this is the first thing. I think we have the most advanced the material solution for those companies. That's first. Secondary, I think we have the full product line. So again, I mentioned you have those kind of packaging, you use a separate material. You don't want to use the one material from the different company, one each, which is a disaster of management and reliability issue. So some company provide a product A, some company provide a product B, some company provide several material, but as a completely product line, and we are one, and not so many. Again, we believe we also we do have the volume, advantage because we have the fully automated product line in our two sites. One is in the Shanghai area, another one is in Chengdu area, West China. Fully automated product line. We have produced this material day and night. Okay, very high volume. The efficiency is very high. The volume, because of the volume, so the supply chain also very competitive. So I would like to say we can provide the most competitive in terms of the price and the volume, provide those kind of material to our customers.
Yeah.
Growth future in India. And we understand in this area, we understand the Chinese, what they are coming from, and we can quickly. So the first phase, we want to be your very valuable supplier. Through our the collaboration partners, we want to be introduce the material to service your needs, to help you solve your battery problem. That's the first phase. Second phase, we want to fully participate in the Indian, the development. Basically, we want to say we're going to put our local manufacturer here. We would like to grow with you. And
what about the R&D facility? Are you going to basically set up R&D facility along with the Chembond here in India?
With the different city?
Yeah, R&D facility, development facility.
R&D.
This is okay. You are ahead of my, But I think this is very interesting, and we definitely. I think India has a lot of talented engineer, and we, as one of our experience, we come here for the presentation. We're talking. We are facing all the kind of engineer, very tough question, very talented question, and give us a very hard time. Today is a Saturday night. I believe you guys give me a break, so didn't give me a very hard time. Anyway, so. We definitely, I think India has a lot of talent. So we are looking for not only producing the material here, we want to have a valuable, the co-development with all our Indian partners. We are for sure. We want to be the Indian R&D as our, overall the worldwide, the Darbond, R&D facility here. I think thank you for your reminder. We should prepare for that.
Yeah, I have another 2-3 questions. The presentation was very excellent and giving entire detail about the product features. The one thing which is missing is that you are not explained us about the validation and testing of electric vehicles or your material. How much actually it is actually withstanding for number of hours or number of years, or you say that it has to be work at cold and hot temperature. But the point is that you are not mentioned about the duration, what type of testing you do it for your product. So that was a missing point. And when we talk about you put all these are all chemical. When you put in the vehicle, how much, because it's not like a steel that it can go in India, the average life of a vehicle of 15 to 20 years. Whether this chemical will withstand for 15 years or 20 years without the maintenance. We like to understand from that.
Yes, that's a good question. Automobile industry, they have very, very high, reliability requirements and also time requirement. Bottom line, we have all the data there, but today the emphasis is we give you a high level. We meet our customer requirement, right? If you want specifically the product, how much we can go through the high temperature or shock environment, and we're glad to provide all this data for each of the materials.
Yeah, the last question is about the raw material. So when we talk about, because mainly raw content what you have shown are the epoxies and PUs, may they be unique in the nature, but if suppose you want to plan to put the plant in India, the raw material sourcing you are going to do it from China, or whether the local material will be also available to generic raw material like commodity product like epoxies and PUs and others.
Okay. Also, please allow me to. So we do have a very sophisticated, very huge, the database for this material you develop. We have, I think, tens of thousands of database for all the kind of material application, different battery, different design. I think we have the most, the complicated database for this one. Secondly, the development, the cycle is quite long. We have the basic, the material property. You work with the customer, for example, CATL. They do an modeling. They translate their modeling to material requirement to us. Then we come out with the basic material properties, which probably take several months. And then you go through some previously testing with the customer, which is not actually put on the package, doing the process, all the kind of testing, going through reliability. This is the second, the phase. The third phase is you have to put in the pack. The pack has to be into the vibration, and sometimes you actually go into the real car for some testing, which that last phase takes several months. Then you go through from the scale and from the volume scale, those kind of things. So I think that you come out with one material should be more than a year, something like that. Okay. So
thank you.
Yeah.
Thank you.
Okay, thank you. The second question is from the raw material. Our situation right now is majority material we are able to sourcing from China, the China market, because China is really there's a lot of industry anyway. So we do have material come out from some from European and also from American market. I think this is the raw material, I believe. I think this is anyway, this is still open market. We are looking for all the kind of material. If we are able to come into the Indian local market, we'll see if we can use as much as the local material locally, which actually improve our the competitivity and also help the production help the bio environment in the one the market. So.
Another connected question is about the material content what is used in the battery, electric vehicle. Many chemicals are getting involved for during the manufacturing of electric vehicle. The content of the raw material will be much more higher. Then what is the basically innovations what you are driving? How you can reduce, because from sustainability point of view in the future, how you can reduce the total consumption in per car. So that is another challenge. Whether you have R&D is working on that part also. From one side you want to put more raw materials more, and from other side you want to reduce the consumption in the vehicle. Increasing the performance by reducing the consumption of fuel material.
Use of fuel material. Right now, for use, the fuel material is based on the total design. As I mentioned, they use a side panel. Before they don't use a side panel, they use some belt. Those is one kind of, we try to use, there's two things. One is you try to make the material lighter and lighter. The density is lower, which we do have some technology here. Normally you have this kind of density is more than 123, 127. We are now have a material density is lower than 1. We are coming out of material has density 0.07, 0.0, even 0.06, which is one way. Secondary, I think we can make the material use the material volume less and less, which means your material property has to be high performance. Less volume, you can have the same, the quality or the performance, which is really challenge. Which is, but this requirement is also raised by our, the customer. They also, yeah.
Okay, thanks.
This is Vinod from Tata Motors. So first of all, compliments for developing the entire range from semiconductor to back connection. So in fact, in automotive, it's a series of components and then we integrate. So all along, when it comes to power electronics or integrated electronics with battery pack, we have a challenge always that whom to blame if there is a problem of say sealant failures. So once a credible partner like you is there who has got a complete spectrum of sealants, I think, and adhesives, that's going to be a absolutely blessing in disguise. So thank you for taking us through the beautiful range. My question is, number one, in case of battery pack adhesive, I was not able to locate the FMVSS compliant because in India there are regulations evolving that if the fire originates, it has to douse within certain time. Now I think it is within 3 minutes. I'll have to just cross check. So these regulations are becoming stringent. So I could not locate properties on those lines. So in the adhesives which you have shown for the battery specifically, have you checked it for FMVSS compliance, and then what is the flame propagation rate?
I think we are aware of all these regulations and so on. However, we didn't have time to go through the details on how to comply with India's regulation. I think it's a very good question. I think when we have that state, we're going to work with our partner to fully understand the regulation.
Regulation and environmental.
Yeah,
And the rating of your product.
like a UL.
Yeah. Okay. If I can answer you correctly, all our material right now is meet all the European and the market, all the kind of regulation requirement, REACH, ROSE, and ELV. Is that ELV or those kind of requirement, all standard, and all our material goes to the European, market. For example, as I mentioned, BMW, Mercedes, whatever, they are using actually their lithium battery using some the China manufactured battery and with our material. That's one thing. Actually, we have encountered those kind of questions during our visit with a customer in India. I think this is very good. India is very awareness of environmental and healthy and safety issues. Then I think. Right now, there's a trend to try to using more and more of bio-based material. For example, like the polyurethane, we are actually provide the material to the airport. The airport has a lot of the wearable, the electronics, all right, you have earphone or whatever. So they are really looking push for you come out with material coming from not from the petroleum based. Come from the bio-based. Polyurethane has those kind of advantage. So there's one direction is we can work together to move into those kind of bio-based, environmental friendly, those kind of material. This is one direction.
Okay, thanks for. Is it okay? I mean, it's a kind of a request if you can provide us a white paper wherein you have done a study of a pack, how it was earlier, and eventually how with the adhesive you are able to provide a value. So it's a kind of a full service. Means one is on the material side, on the other side, you are able to provide a complete design services. Right from the concept to, have you done something of that as a complete full service assignment? And if yes, then maybe we can work with you. Now, what I could see the range of products available with you, we will be able to eliminate many, and it will be a complete homogeneous solution which can be provided. So have you done a complete assessment and then provide overall solution to anyone in Chen? That's the question.
So we have a case study to say provide some advantages for the existing case study.
I think you can prepare it.
Maybe during the dinner we can talk a little bit more about
Specific.
And one last time, and of different sizes and shapes. I mean, for a very small connector, it is very, very tiny. Now, have you ever evaluated the possibility of just replacing them with some kind of a sealant? Just push that sealant into the wire and the job is done. And that will solve the industry problem to the large extent.
For specific case, I think we have, maybe not what we talk about. We work with our customer, right? In this area, when customer have
replaced some other designs. Yeah.
No, it's, for example, even if you connect, say, DC-DC controller,
Yes.
for that matter, any ECU in a vehicle, what you do is it is connected to a wire. Eventually, there is a connector on board on the device. On the wire side, there is another connector. So when you join, to avoid water ingress, there are seals.
Yeah.
So at this moment, those seals are externally inverters. The bigger seals are used, again pre-molded. So if those can be replaced with the seals, for example, there is a bigger connector, you just fill it with the seals and push the wire.
Yeah.
It will solve the problem of sealing as well as it will possibly optimize our cost structure to the bigger extent. That's what I feel.
Yeah, I think I understand it because it's going to integrate a little bit more, right? You become right now you use one, right? Then you have the integrated design, and how do we do not only I'll talk about a lot about the thermal solution for that, but what you're saying, the cylinder as well, and I think we have.
Maybe we can discuss this more.
Yeah, I think in a specific solution, I think we want to please our customer. When the customer, they know our strength is the cylinder, thermal, and structure adhesives. And if they have some specific design, usually we work with them.
I mean, frankly, capability which you are bringing to the table is immense, and I think we should be able to work on this kind of innovative solutions.
Okay.
Thank you.
Okay.